Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to watch it again later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can during today's webinar. We also have 2 polling questions during the presentation, so please, hopefully we'll get you guys engaged and you can answer some questions for us. And finally, at the end of today's webinar, we are doing a drawing for 2 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Your Code Isn't Static, Your Processes Shouldn't Be Either. Our speaker today is Alex Rybak, who is the Director of Product Management at Flexera. Hey, Alex, how are you? Great to see you.
I'm doing great. Thank you, Charlene.
Awesome, awesome. Well, I know you have a great presentation on tap, so I'm going to take myself off camera, put myself on mute, and let you get right to it.
All right. Thank you so much. Thank you, everybody, for joining. As Charlene mentioned, I'm Alex Rybak. I'm Director of Product Management at Flexera, and I focus on our software composition analysis products. So this webinar is Your Code Isn't Static, Your Process Shouldn't Be Either. It is really focused around DevOps as well as SCA and how to marry the two, how to make sure that your process is dynamic based on the market we're in and based on the nature of code that we audit and scan. It's really important to make sure that you think of all the risks and think of all the opportunities to both make life easier for engineering as well as to make sure that you're up to date on your knowledge of what's inside your code. So today I have it broken out into a couple parts. First half of the webinar is really going to be about the history of open source usage and how we arrived at where we are today. Some bellwether events that occurred in the past that really have driven the market. And then talk about, given all that, where do we go? How can we deploy SCA to be effective? How can we integrate it with engineering processes? And then talk about other topics that are relevant to this conversation. So the first thing I wanted to do to get started is make sure that we have a common understanding of how we define software composition analysis. So we talk about this as products and services designed to document your dependency on open source and other third-party software. And the important thing to note here is it is product, services, people, and tooling. All right, this is not a push button, get everything done. It's not a fully manual deal. It's really important to find the right balance for your organization, depending on various things that we will talk about. And it's important to understand that this is like any other process. The more you put in, the more you think about it, the better you design it, the more you integrate it, the more effective it'll be on the other side. The reason companies do this is because open source has become very pervasive over the last few years. We have a fairly large audit practice where we look at customers' code and perform the work on their behalf. And we typically see up to 80%, in some cases even 90% of the code that we look at is actually comprised of open source software. So it's a big element of customers' code bases. It carries with it inherent risk like anything else. And the 3 that we really talk about is number 1, security risk. This results from anything that you did not write yourself. If you're using other people's work, then there is potential for security issues to sneak into your products unless you're aware of your supply chain, and we'll talk about that. Second one is IP risk. This talks about needing to make sure that you respect people's intellectual property. If you're using somebody else's code, typically it's governed by an open source license, and that license has obligations that need to be fulfilled to comply with the usage requirements. And then third is reputation risk. This is really associated with not wanting to see your organization in the news. There's been a lot of news events in the past few years around some very prominent security problems, and lots of company names that we all know have kind of gone through the papers. So combination of balancing security, IP, and reputation risk is really what SCA is about giving you transparency into the code that you use, and giving you an opportunity to make sure that there's a process in place to properly manage the risks associated with it. The other thing I really wanted to start with is this graphic. I saw this on LinkedIn a couple weeks ago, and actually it was in a security context, so I've adapted it a little bit to SCA, but I think it very accurately depicts immediate perception that engineering, who's typically the folks that are chartered with implementing an SCA solution, their initial response, right? It's another thing that they have to do. It's typically something that developers don't wake up in the morning wanting to go to work and getting all jazzed up about fixing compliance problems or fixing security bugs, right? But by their DNA, developers are really all about wanting to innovate, wanting to solve difficult problems, and wanting to make their products and services better, not squashing bugs and trying to burn down technical debt. So this is typically the response that we see when you ask questions around, who's going to do SCA today? But the whole point of this presentation is really to talk about the fact that this should not be feared, right? It's a process like anything else. The key is to understanding what risks you have, what your tolerance is as an organization, and then adapting the process to work for you. So let's start by talking about evolution of open source use. And to me, the most logical place to start would be the build, because as open source became more and more prevalent in today's development environments, the fundamental concept around how we build software has changed. So if you go back a few decades, it was very common for your organization to have complete control of the code base. If you ever contracted work out to a partner, for example, you would typically have rights to the source code coming back. You would then take care of the compilation and you would put it into your products. Today, the world's changed. A lot of code is being leveraged from open source community, which means there's lots of eyeballs on it. There's lots of people working on the code, fixing bugs, innovating in the code. And typically they're outside your organization. So your level of control is significantly lower than what it would have been in the past. Open source is always being modified, it's being improved, it's being reused as derivative work, and it could even be modified by your internal teams when it gets pulled in. So the real big difference becomes your level of control, the provenance of the code, and kind of your chain of custody is very much diminished over what it was in the past. So all that is not a bad thing, right? But it just introduces risk that needs to be managed. The second element to this is the number of entry points of where code can come into your organization has significantly increased. And again, the root cause of that is the fact that your build essentially has been opened up to the outside world. So it is not uncommon today to rely on a vast partner network to leverage open source projects, to write your own code, to have supplier code, to have commercial code. As well as all of that, it's always important to understand all the different forms that the code may be injected in. So you may pull down a monolithic package as part of a build dependency. You may rely on a container developed by another organization. You may have build dependencies for code as well as other artifacts, right? You may be pulling in source code that a partner developed for you and you're statically compiling it into your product. You may be downloading binaries. You may be pulling in media files, multimedia files, codecs, images, icons, documents. It's a very complex world, right? And these are kind of complete entities. But then you're also open up to copy paste events. Your developer may have been influenced by reading an article or a blog or a book on how to implement a particular function. And it's very likely they may have taken some sample code and put that into your product, which again, is not a bad thing. It just needs to be done a proper way. And then of course, there's always commercial code. So in essence, what this slide really depicts is software has become a supply chain, right? It's not different from the hardware supply chain. When you look at organizations that build large complex products, so planes, cars, very rarely do they build all the parts, if ever, right? Typically, there is a vast supply chain. There's a lot of partners, a huge ecosystem. And the company that is building the ultimate product that they're selling is essentially responsible for defining the level of risk and the level of quality that is acceptable for the products that they take in that they then use to build the final device or the final vehicle. No different in software. In software, you are ultimately responsible for what you deliver to your customers. And if you happen to be leveraging open source projects or leveraging partners, suppliers, you are responsible for the code you're taking in. So it behooves you to make sure that your supply chain is, number one, understood, that it's transparent, that you've discussed this with organizations you work with or individuals you may be leveraging, and that there is transparency and understanding of what you are receiving from them, so you could do the right thing downstream to push it down to your customers or perhaps other vendors that write their code on top of your code. So we'll come back to this topic later, but I wanted to introduce it here. The third thing to really talk about is dependencies. And this has been by far the biggest thing that's really driven the volume of open source. We have, as Flexera and previously to that as Palamita, done a lot of research every year into tracking two numbers. And we do this by, as I mentioned, we have a fairly large audit practice. So what we do is we take the last 12 to 15 audits every year. And we've been computing this since about 2006, but here the last 8 numbers are shown here. And we kind of track two numbers. We track a number of when we engage with a customer, how much are they able to tell us? How many pieces of third-party materials do they know that they use in their code? So these numbers are represented by the black bars. Then what we do is once we have done an audit, and I want to full disclosure here, right? This is based on a machine finding things as well as based on the human digging deeper through the various manual analysis techniques we support and further manually refining the bill of materials. And that is represented here by the green bars. So you could see two things. Number one, the level of disclosures has pretty much been flat and very insignificant. And in fact, if you look at it compared to the level of average items found in an audit, it's actually percentage-wise going down. However, there's a pretty big increase in the overall composition of code bases. The average number of items that we typically find in an audit these days are in the upper 600s, whereas they were around 200 or so in 2012 and under 100 before 2010. So sometime between 2014 and 15, the use of package managers, which is a technology used by builds to automatically pull down dependencies based on what engineering has specified as required software for their code to function. The use of them became very popular, and the ecosystem around various programming languages and their corresponding repository managers has really grown. Beyond that, what we've seen is there's been a lot of package managers that have become technology agnostic. It is just a repository of various types of open source material, and you can very easily tell your build that I need to go pull down a particular set of packages because I don't want to re-implement that code. The consequence is all of these packages will have their own dependencies, and the transitive dependency chain can be very deep and very long. And what that means is, although you may rely on a small set of packages, when your product is fully compiled and assembled and built, you may end up with hundreds of packages that, unless you are paying attention, you don't know it's in there. And that is a big source of unmitigated code. And that is what people really need to focus on and understand, that this is an element that's really important to manage and be able to track so that you can manage it up to your level of risk within your organization. So the next thing I really focus on are 3 stories. So 3 cases where there has been an issue in an open source package. Again, this is not intended at all to be kind of a negative cloud of open source or use of open source, right? Open source is a great thing. Like anything else, it allows you to really focus on what is the core competence of your company and being able to save time on things that are constrained or well understood in the market. But like anything else, it's outside your organization, therefore it's got to come with a level of risk, and a level of attention needs to be paid from your end to make sure that you're properly managing the risk. So 3 stories I wanted to talk about to explain the consequences of not knowing what is in your bill of materials. So the first one is LeftPad, and I'm sure a lot of attendees have heard of all 3 of these. So LeftPad was a small utility, 11 lines of code. In fact, you can see in the image there, that basically just help you to pad a file with some white space. The challenge with LeftPad was that it was extremely popular, and it was linked to tons of projects in the Node package manager ecosystem. The developer of LeftPad in 2016 had several legal disputes going on with various entities, and this developer had provided a few hundred different pieces of code into the Node ecosystem, and one day decided to take this down due to those disputes. So the consequence of this was the moment this repository went down, it was linked to a bunch of people's code. And suddenly builds started breaking because they were unable to pull down a copy of the left back code. So people scrambled, it got rewritten, dependencies got updated, but the fact that there was a dependency in place for organizations that understood it and monitored it, it was something that a build failed, they understood what happened, they went and addressed it. Organizations that didn't pay attention to the dependency chain, they had to spend a lot of time to really understand what is going on, who put in dependency, is this code we need, can we rewrite it, do we have the right to rewrite it? So all of these issues really came to the forefront. And it just shows that it's important to really understand that you need to not only understand things you depend on, but you need to really inspect the downstream consequences of pulling in packages. In some cases, you may want to clean it up and remove elements that you don't need. In other cases, you just want to make sure that you understand why you're pulling something in, what's the consequence of it not being available, what would your remediation be, and just knowing what happens if a build fails. Second thing I want to talk about is struts, and this was probably the most prominent security event in the last several years. This was back in 2017. A lot of you know this as the Equifax breach. But the interesting thing here is that the component that was at the heart of this issue was something that a ton of people used. It was something that had been reviewed. It was very favorable. It had a nice business-friendly license. It did not have any egregious vulnerabilities at the time. And typically this was on people's whitelists, right? It was a component that everybody was fine with using. It was from Apache Software Foundation, which is a well-respected organization. It wasn't from some unknown developer in some country. This was a large organization, lots of people, lots of developers, really good pedigree, kind of good history. And yet kind of this innocuous component ended up overnight becoming toxic. And kind of the story here is you can't just look at something, review it, say that it's okay, and then forget about it, right? The key is that things change. Very often components may be completely fine today. Tomorrow there may be a new security vulnerability, or the way you use a component, maybe you use it in a way that didn't expose you to a vulnerability, and now you've changed the implementation in your code. And now perhaps you've opened up a function that previously was dormant, and now a vulnerability impacts you. So it's important to understand that this is all living, breathing, live code. It's important to have a process that circles back, a process that has a proper alerting setup, and a process that notifies the right people that then know what is the right thing to do in their organization. The last thing you want to do is have to deal with all this real time with no pre-planning and no real kind of design processes in place to address these issues, because they will happen. The third story I want to talk about is event stream, and this one's interesting too, because this has to do with a dependency, but it has to do with a dependency and a change in ownership of a given component. So event stream was, again, a very popular component, again, in Node, the Node ecosystem. And it was a component where the developer basically stopped maintaining it. And another developer took over, and they wanted to add a new function that required some code that they were either going to write or try to reuse from open source community. And they chose to go out and add a dependency for event stream to a component called flat map stream. And that component in version 0.11 happened to have a really bad vulnerability. So by making this one line change in their code, they now tainted their version of event stream with a vulnerability. And everybody that depended on their code, which were a ton of projects, suddenly now had a 2-level deep dependency with a vulnerable code. So now not only does event stream get tainted, but every single product pulling event stream in now has a security exposure. And again, it's kind of similar to the first story, but in more of a security context, right? Not understanding your dependencies, not understanding that your dependencies need as much security attention as you would put on your own code using static and dynamic security testing tools. It's really critical to understand all the code that is coming into your company, to understand how you are discovering it, what you're doing about it, what are your policies, how do you manage it, and how do you fix it if an issue occurs. Okay. Okay, so now I want to shift focus a little bit and talk about, well, who is mandating that these things are done, right? Why do people even bother doing SCA, right? Is it just kind of an emerging thing? Is it something that's really disruptive to businesses who don't do it? So I wanted to talk about this in three contexts. So first context of who's doing this is people that, based on what they do for a living, based on where they are in the supply chain in their industry, based on who their customers are, uh, may not have a choice, right? If you want to conduct business and you want to sell to the government, to defense, to certain regulated industries like healthcare or finance or government or military, it is very likely that they are going to impose requirements on you to disclose what is inside your code before they will take it from you. So these industries typically have much lower risk tolerance than others. They are core to either things that are confidential as far as government defense goes. It could be things that can hurt people or harm people, right? So vehicles, autonomous driving cars, healthcare devices. So these are things you will typically have a much higher standard of care. And if you happen to sit in the middle of a supply chain where your code ultimately ends up in one of these devices, expect that before somebody will buy your code or take your code, you'll be asked to provide disclosures so that they understand what risk they are inheriting. The second part is a little bit softer. It's really all about best practice, right? My competitors are doing it. I should be doing it. My customers typically are not in the must-do category, but they feel much more comfortable with me as a vendor if I can provide disclosures because it shows that I've got my process under control. So it's really done for several reasons. One is, in some cases, it's just easier to proactively provide disclosures than have to scramble and react if somebody asks. It's very common in licenses where attribution requirements are mandatory. And in some cases, depending on which license you use for a particular package, distribution of source code may be mandatory. So it is a lot easier to do this as part of your process than to suddenly have to scramble and try to piece it all together if a customer or some industry group may come after you and force you to do this. The second thing is competitive advantage. Having your house in order, being able to quickly provide disclosures if asked, gives a perception that you're more trustworthy. And it's true, right? If you have a process that's well thought out, if it's been designed to reduce risk, and it's something that you can follow and something you can produce an artifact for and deliver to your customers, you will be perceived as having your stuff together, being able to reply to commercial requests, and perhaps have a more favorable perception than a competitor. And the third is really to mitigate regional distrust. So if you have development happening in countries that are not as likely to protect IP and to respect people's intellectual property, this is a way to make sure that whatever code you may be taking in from those places get scanned, get vetted, and hopefully even get tooling put into the organizations that you work with that develop the code to make sure that things are more transparent and you understand what risk you are incurring by taking the code. And then the third is really about what are we seeing? What is Flexera seeing out there? So we have, starting last year, begun to see language in contracts. So when we sell our software to customers, about 10% of the time, we are starting to see that they are demanding not only a disclosure of the open source in our code, but in some cases, give us high-level bullets on the parameters of your solution. What does your governance program look like? How often do you scan? How do you remediate? What are your security policies? What is your turnaround time, your SLAs? So these are things that typically were always kind of buried in engineering under quality software. Now they are being surfaced as part of contract negotiations and commercial discussions before a deal can move forward. We've also seen cases, and this has shown up a couple of times now, that we've seen where during M&A transactions, there are underwriters who secure M&A deals, and as part of the language and the contracts they put together, they ask questions like, does the company use open source? What open source software audit was performed? How often is it done? Does the company then comply with the recommended remediation actions? All right, so these are no longer best practices and no longer things that may be good to do. In certain cases, again, certain industries, and depending where you are in the supply chain, you will not be able to push your product to somebody if you don't comply with this. We've also had a couple of things happen where the only reason we've done an audit for a customer is because their own customer demanded it. All right, this was not a proactive case. This was I'm trying to sell my software to somebody, and absent a disclosure, they will not buy it. So we need a rush audit so that we can prepare that disclosure. We're also starting to see things at the beginning of sales cycles where prospects we speak with as part of RFIs and RFPs to kind of get information about our products. There's also a section on open source, right? So it's not just how our product works, but there's questions around, can I trust that you are doing the right thing to give me a secure product, secure application? And likewise, we impose this on our vendors. If we subcontract out development of a utility or some sort of tool, we will definitely not only ask for the code, but also ask to see what type of audit was done on their end and what open source has been used as part of that development work. So that's kind of the range of things we see, all the way from must-dos to best practices to real life what we're seeing in the industry. Okay, so this point here, I wanted to talk about kind of we're kind of on the precipice here of lots of organizations. You can see the logos on the bottom are all really circling around the same thing, is in their respective industries, whether it has to do with financial transactions, or it has to do with privacy or cybersecurity, or the US, so FDA, for example, about securing products that can harm people. There is a circling of various desires to put in place requirements to ensure the software bill of material is transparent, properly produced, and available to people. And if you look at all of these different initiatives, there's really four kind of main elements that you can tease out as common requirements. First one is to maintain an up-to-date software bill of material, so it's called an SBOM, of all the open source software components in your applications. Second is, once you have a bill of material, you need to use it to determine which elements in that bill of material have security vulnerabilities and have a process to be able to do this ongoing, as well as not just know at the time that you're looking at your bill of material, but be able to monitor and understand what happens if a component's quality changes. Right, a component may have a new vulnerability. It may have diminishing participation by the community on development. So perhaps it's becoming stale and industry is switching to a different component. So all of these things go ultimately into component risk. And then the final part is be able to have a policy, so an SLA on how quickly you react to the news, as well as a patching process. All right, so know what you have, understand what's vulnerable, keep monitoring it, and be able to have a policy on when and how you're going to patch any sort of issues. The good news is, if you follow a continuous software composition analysis process, all of these requirements can be satisfied with the process. So we'll talk about that. So let me spend a second here and define what we mean by this, right? So continuous SCA essentially means to evolve from, we're going to audit our code once a quarter or once a year, or when somebody asks us to we are going to get ahead of it. We're going to become more proactive rather than reactive. And we're going to put a process in place that helps us integrate, monitor, alert, and initiate fixes. So when we talk about integration of SCA into the engineering tool chain, there's several places where it makes sense, and we'll go over these in detail. But there's things like artifact repositories, right? So before you actually write any code, any components you're thinking of using should be vetted. There's development environments for where developers write their code. Don't wait till the build occurs. Give them an error right there so that they can fix it as early as possible. Source management systems, right? CI/CD builds. Every time there's an automated build that occurs, there's an opportunity to scan. Don't forget about containers, right? Your product may be completely clean, but it may rely on another application that's in a container that hasn't been scanned, and suddenly the customer's environment is no longer clean. And then issue trackers, right? So there's an opportunity to integrate back into bug tracking systems, so any sort of compliance issues that are uncovered naturally flow back into the engineering backlog, get triaged along with any other type of bug, and just become part of the contract of what engineering does to produce product quality. Important, again, we talked about this before, is to actively monitor, right? Just because you have a bill of material up to date today doesn't mean that 5 minutes later a new package may be pulled in, something may have been updated, package may have been replaced. So it's important to keep up to date, as well as There may be new vulnerabilities for existing packages that were perfectly fine at the time they were reviewed. So they need to be continuously monitored. The reason you would monitor is to provide appropriate alerts, right? You need to alert the right people at the right time of any sort of non-compliant cases. And these could be new security vulnerabilities or other criteria that's important to the organization. And then most important is once you've alerted them, what do you do, right? What's your remediation and patching process? How long does your engineering team get to fix a vulnerability that's been reported by a customer or a vulnerability that's come out of your own scanning, right? Do you have to do it immediately? Do you have to do it in the next release? Do you have to do it in a certain amount of time? These are all things that need to be part of the policy so that you're not scrambling when these events occur. Okay, so let's talk about scanned context. So this is kind of the intersection of SCA with the engineering lifecycle, and what are the various scan events and when does it make sense to do them? So the first one is artifact repository, right? These are essentially areas where a company can choose to lock down their open source packages to only be used once they've been vetted, right? So as opposed to having your developers go out in the wild and try to find packages that they want to use across various repositories, you may choose to put in an internal artifact repository. You may choose to have controls over what gets in, what gets out, what are the allowed uses, have an inbound review when a new package is added into the repository so that any downstream uses now have much less risk coming along because you've already vetted the component. Likewise, if there is an issue with a particular artifact later in time, you should have an understanding of where it's been used and what you can do about it. Okay. The next is IDEs. So IDEs is where a developer does their work, and it is a place where you have the opportunity to get in front of the developer as early as possible, right? It's a place where you don't have them write the code and then check it in and then realize that we could have fixed the issue early on in the process. So this is part of kind of the shift left or expand left movement. Think of it as a smoke test, and it's an opportunity to be able to let the developer know as early as possible that they are potentially modifying a manifest file that will bring in a version of a component that is known to have a security problem, and therefore go ahead and fix it right there, kind of at the root of where this is happening. The third is during the build. This is kind of the most intuitive thing. So the build is where all of the check-ins come together, and this is the first time that you are building your application or your product around the latest set of check-ins. So naturally, this is a great scan event. This is typically where we recommend people start. And this is something that can be done continuously or maybe as part of a nightly build. But the idea here is every time that there's a build, you do an assessment for composition. You understand whether you have any quick fail policy violations and either use it to fail a build or use it to quickly put bugs back in the developer backlog so that issues can be fixed before the next build occurs or before the next day comes in for new fixes. Then you get into kind of the more ad hoc, and this is really the world of deep dives. And the thing that's important to understand is if you talk about DevOps and you talk about integration, then there's no human process involved, because if there's human process, everything's going to slow down. So we always kind of talk about there's two parts, two streams to this. One is an automated stream, right? Here you're doing automated scans, either again in the developer's environment or as part of a build. And the objective here is to quickly fail, right? It's to find any sort of policy violating content that you want to catch early and often and be able to drive the rest of the process based on the finding. A deep dive is a case where perhaps you are seeing that there's a lot more violations than you expected. Or perhaps when you're doing your automated scanning, you're seeing that the bill of material items that are coming out are surprises to you or your team. You didn't realize that you're dependent on, for example, Spring, which has a bunch of different jar files, which then have a bunch of different downstream dependencies. So if you're starting to find a lot of surprises, a lot of kind of head-scratching results, that may be an indicator that you want to go and look deeper in this code base and really understand what's going on. So deep dives are a way for you to move the code to our product, for you to either manually upload it or use source management plugins. and then have an analyst manually look at file level results, dig deeper, identify things like exact file matches, source code, copy paste events, where you're going beyond packages, but you're actually looking at things like fragments of code and more forensic level results. So that's always an option. We typically say that this really needs to be driven by heuristics and understanding where the risk is high. Organizations need to select if this is something that's appropriate for them to do. And then finally, containers, right? Don't forget about the fact that, again, even though your product is clean and your product has been vetted, you are not alone in the world, right? You typically depend on other applications. You got the database, you got the operating system, you've got complementary utilities or tools that may be used there. So it's important to understand the entire ecosystem, the entire platform, not just your application in the silo. Likewise, if you're deploying your product as a container, it may pick up other elements along the way. So it's important to not just scan your source as well as the build output, but any sort of containerized elements that you may be deploying as part of your product going live. Okay, I believe we have a couple poll questions here, so let me hand it back to Charlene for this.
Yeah, okay. Give you a little bit of a break too, Alex. So our first polling question is going out right now. What solutions is your organization leveraging for product quality? Select all that apply. Let's see, you can choose from SAST, static application security testing, DAST, dynamic application security testing, IAST, which is interactive application security testing, SCA, software composition analysis, or SEIM, SEIM, security event and incident management tools. Go ahead and make your choices. And while you're doing that, I just want to remind the audience real quick that we are taking questions from the audience. So if at any time you have a question, please, you don't have to wait for the question and answer period. You can go ahead and submit your question anytime. And hopefully we'll have a few minutes near the end of today's webinar to go through the audience questions. Okay, let's see. I'm going to give you guys about 5 more seconds to go ahead and make your selections, and then we'll go close this out, take a look at the results. Okay, I'm going to go ahead and close the poll now. And here are the results. Looks like the majority of folks are using security event and incident management tools, followed closely by static application security testing. Alex, did those results jive with what you're seeing in the marketplace right now?
They do, actually on both ends, so it's good to see. I did expect the SaaS number to be much higher, so that is something that's very complementary to SCA, where SCA focuses on the open source security part, whereas SAST and DAST will focus on code that you wrote yourself. So, together it's good to see the numbers trending upwards.
All right, great. So I'm going to go ahead and hide these results and then push out the next poll. We'll go ahead and get both of them done for you. Here's the next poll. It should be on your screen now. What is driving your organization's need for open source management? You can select from one or more of the following: security vulnerability management, license or IP compliance, export controls compliance, safety compliance, or that ubiquitous other. So go ahead and make your make your choices, and give you guys about another 20 seconds or so before we go ahead and close this polling question out. And also, again, quick reminder, besides the question and answer period at the end of today's webinar, we are doing the drawing for 2 $50 Amazon gift cards. So please make sure you stick around, because if you're not here, you're not going to be eligible. So please stick around, and as I said, we'll have 2 drawings, one drawing for 2 Amazon gift cards. So, okay, I'm going to give you guys about 5 more seconds, and then we'll close this out. 5, 4, 3, 2, 1. Okay, closing it out. Let's take a look at the results for that one. Oh, wow, it looks like almost overwhelmingly security vulnerability management is driving organizations' need for open source management, followed closely somewhat by license and IP compliance. Alex, again, jiving with what you're hearing?
Jiving with what we're hearing, definitely. Also good to see that safety's in there. So that's definitely one of the industries where risk tolerance is extremely low. So that's another big driver here.
Excellent, excellent. All right, well, I'm going to hide these results, let you get back to your presentation.
Okay, thank you. Okay, So I wanted to switch gears a little bit here and talk about some other considerations, right? So we've talked about kind of how we got here. We talked about what is SCA and what are the different kind of elements of process and various scan contexts where it makes sense to introduce scanning and potentially some manual process as part of your development lifecycle. Now I really wanted to focus on kind of some more industry topics. So first one is education. And I think this is huge because it is very difficult and in fact, very unfair to expect engineering organizations to understand why this matters and to kind of enthusiastically play the game when their education typically did not cover this. Right? Most likely where we see organizations failing is if this purely becomes a mandate without education, without context for engineering or whoever else is participating as to why this matters to the organization. So Forrester did a poll a while back, and they reported that if you look at the top 40 US and top 5 international computer science programs around the world, none of them included licensing and secure coding in its curriculum, right? So what that means is unless you happen to be taking a modern online CS program that is either in Silicon Valley or some other kind of hotbed tech area, chances are your education did not cover this. Right? So I have a mechanical engineering background, and we had a lot of emphasis on ethics classes, which is kind of the same idea. That is not the case in education today. So what this really means is the burden is really being put on industry to cover the gap. Either it needs to be part of onboarding new developers into your organization, or it needs to be part of their ongoing internal recertification, right? Just like you would do annual classes and training on harassment or your HR policies. This is really something that needs to be an ongoing message that goes back to engineering to explain what the problem is, explain why the company is investing in doing this, explain what their role and accountability is in the process, and then kind of the downfall of what happens if they don't do it, right? What happens if this doesn't get done? How does this negatively impact your business, the perception of your organization, as well as their career? Because wherever they go after this, chances are this is going to be a requirement of any development job going forward. There's a few links at the bottom of the screen here, so when you get the slides, you can certainly go up to those, but we've got a partner, Source Code Control. They've got some great training. The Linux Foundation has some really good training. Udemy and other kind of online classes. There's lots of good content out there. So certainly would recommend that if any of you are working through your SCA programs and development has really not been brought up to speed on why this matters, very critical to make sure that that's done. The other thing we've seen that's been very effective is, and there's different names for this, but companies setting up an open source review boards, so OSRBs. This could be the open source program office, right? They've got different names. But the idea is it is a tiger team of people that have roles around open source use at your organization. So this could be narrow around open source only. It could be expanded to cover all third-party assets that come into the company, perhaps even everything, including commercial. But the idea is you get a small focused team of people. They're typically the ones that participate in reviews, help formulate policies, help organize and develop training. So it's a way to reach out to everybody at your company and make this a known thing. Second thing I want to talk about is supply chain, and we talked about this a little bit, but the supply chain rules are changing. So a while ago, it used to be pretty common to say that if we are part of a software supply chain, since we don't really know how much open source people use, we try not to use much ourselves, we don't have a process in place, there is a hard no on any open source for contract development. This was something we saw a lot with our customers maybe 5, 6, 7 years ago. That has definitely been replaced. So now there's an evolution towards contractual policies, inbound reviews, and tooling. And by tooling, I mean, I would like to pay you to build some code for me, and here is a tool you must use to certify your code before I will take it. All right, so we're seeing a lot of that being done. We're seeing a lot of push towards vendor self-reporting. And again, all of this is with the end goal to increase trust and transparency along the supply chain. Because again, remember that whatever you end up selling, you are liable for whatever others have done on your behalf. So the more controls and the more gates you can put in place along the way, the easier it will be for you to be able to manage the risk in your final application or product. And then the third is the move to the cloud. And current events are forcing a lot of companies to rethink how they deliver their products. We're seeing a lot of traditional desktop applications and services moving into the cloud. And typically, which was already happening, but it's really being accelerated right now. So when you talk about move to cloud, you're really talking about two things. You're talking about, number one, perhaps your users are more distributed than they may have been in the past. You also have much more frequent releases, and you have much shorter durations in between releases. So that all points to automation, automation, and automation, right? So the less time you have to fix something, the faster you have to deliver the fix. The more exposed you are because your code is out there available, not behind a firewall, not on-prem on a controlled and locked down server, the more threat vectors that opens up and the more amplified any sort of security vulnerability exposures become. So it's important to significantly understand that you're increasing risk significantly for engineering time pressures, right? The cycle just turns faster and faster. And you can't really rely on human processes at that point. You have to have automation, you have to be integrated into engineering toolchain, and you have to at least have some basic level of full end-to-end automation with proper alerting to be able to stem the bleeding and to be able to hit the most egregious issues quickly. Okay, so I wanted to wrap up with some key takeaways and then happy to take questions. First is evolution, right? This whole webinar is all about evolution. It's really about engineering teams really need to evolve their process technology. It's being done in a lot of different areas. SCA is no different. Security management is no different. There's competitive pressures, there's time pressures, there's lots of digital transformation going on. There's move to cloud. So there's everything that's fighting against, give me a moment, let me take my time, let me do this right. So the only way to really address that is to make sure that there's more automated results, there's more intelligence coming back to engineering, and that things are caught as quickly as possible and as early as possible so they can be timely addressed. Second is about awareness. Most organizations are still very unaware of how much, and more specifically, what open source they're actually using. We've typically reported the 6% number. That's really based on our sampling. If you look at actual complete set of audit data for 2019, it's really closer to 1 or 2%. So the level of knowledge as far as what can be put in an Excel spreadsheet before we engage with a customer is extremely low. And even if people do have a grasp on what they're using, typically at best, it's going to be the first level dependencies. It's really rare when somebody understands that by pulling in a package, here's all the other things that are going to come with it. So again, it's important to understand this, important to be able to do your scanning with dependency information and to really understand all the areas that can be bringing risk into your organization. The third is culture. We didn't talk about this too much, but this is critical. It's really important, and this was the reason for one of the poll questions. It's really important to understand what is driving the need or the mandate for this process. Is your culture IP compliance based, or is your culture security based? Very different. When you talk about license compliance culture, it's typically things where you can say, going forward, we're going to do something better, right? We're not going to look back. We've already got products out there, but we are going to put a program in, and we are going to put all of our energy and money and investment into making sure we kind of stem the bleeding, we stop whatever problems we had in the past, and going forward, we do the right thing. You can't do that in security, right? You can't fix 90% of your vulnerabilities. It's going to be the 10 that are going to come back and bite you. So understanding culture really leads you to understanding SLAs, understanding expectations, understanding the level of risk your organization is able to tolerate. And this can very much vary division by division, right? It's not necessarily that your whole company is wrapped around license compliance. You may have the cloud applications that don't much care about license compliance because it's hosted applications and there's really a short list of licenses that they're concerned about. It's going to be security driving most of the demand. So important distinction to understand. And once you understand it, you can better understand your own priorities and how you deal with the results that come out of your SCA program. And then finally, implementation, right? All of this ultimately doesn't matter if you don't act on it. So implementing a continuous end-to-end license compliance security management solution, make sure it's plugged into the right tools so that you're not causing engineering to have to go log into yet another application. Make sure it's timely, make sure that you have discussed policy with all the stakeholders, that you are spending your time on the most egregious and most relevant things based on your own priority. And that kind of most importantly is plan for things happening and have a plan on what to do about it. Right? It's somewhat naive to think that you're not going to be impacted by a vulnerability problem or a licensing problem. You will at some point. So having your plan in place, having remediation thought of ahead of time is really critical to be able to respond to it in a timely manner and not have fire drills happening all the time. Okay, with that, I thank you for joining, and I'm happy to take any questions.
All right, great. So we have about 5 to 7 minutes to go through some audience questions. So if you do have a question, please go ahead and use your GoToWebinar control panel and submit it. Let's go ahead and get to the ones we have so far. First question, we have fewer resources because of COVID-19. Story of all of our lives, right? If you recommend one step to manage open source, what would it be?
Yeah, so unfortunately, yes, relevant. We've been getting that question a lot. We are seeing, with our customer base, with ourselves, there's certainly an impact to software organizations, and impact kind of two ways, right? One is there may just be less people around. The other one, maybe there may be more of a push to change how your products work, right? Move to cloud, more rapid releases, and trying to kind of deliver value faster to make sure that your customers remain. So we always recommend integration and automation, right? It's the easiest way to start. It requires the least amount of human cycles. So our solution has plugins, for example, to be able to easily plug into your build ecosystem. So to me, that's the easiest way to get going. You don't need a human monitoring this, right? You set up the right alerts, you put your policies in place, you tie it into your build, and each build you will get a report with all the red items. So that would probably be the most kind of cost-effective, highest benefit that you can quickly do. And then, of course, if you look at all of these across your organization and you still have time, budget, and people remaining to do the work, then you can intelligently determine where to deploy them, as opposed to just going alphabetically project by project.
All right, great. Let's see, next question here. Do you have any material we can pass on to our company on how to integrate an SCA process to help make our organization turn into a security-focused company? It will be hard to convince agile teams or groups why we should spend more time on SEA per month, sprint, etc.
Yeah, we definitely have collateral. If you go to flexerasoftware.com and you find the SCA section under the Protect menu, there's lots of resources there. There's past webinars, there's legal webinars that talk about kind of speaking points with legal counsel, and definitely can reach out to us through our community site. I'm happy to get on calls and kind of talk about how to do this. We've got some cheat sheets on how to do it. So yeah, definitely I would start there. Start on our website, go to community, and then you can reach out to the various teams through that.
All right, great. I think we have time for one or two more. What are the key elements of an open source analysis process? And how often should the process be monitored to manage change?
Yeah, so we kind of went over this a little bit. So key elements was on the continuous SCA slide. So it's really all about the first and foremost thing is know what problem you're trying to solve, right? It's impossible to do SCA or any other process if you don't know what your definition of success may be. So understand, are you looking to vet every single license used in your code? Are you looking to quickly find and fix any vulnerability in your code? Are you looking to do both? Are you looking to do good enough to provide disclosures? Somebody specifically asking you to do something. So that'll define a lot of the constraints under which you roll out a program. But ideally, kind of similar to the COVID question, is focus on automation first, go as broad as you can, get as many people involved as you can, and then deep dive where the heuristics warrant the need. We provide services, so if people aren't sure how to get started, we can certainly help consult on that. We also provide audit services, so if you're not quite sure how to deep dive or where it matters or where you look for, we've got training and we've got people who can actually do the work on your behalf. So there's definitely support available. But I would just say the main kind of element is understand what problem you're trying to solve, understand who's responsible and accountable for what, understand the timelines, understand the tool chain you have in place, and then try not to deviate too much from that. Try to integrate with it and make it as natural of a process for engineering as you can.
All right, great. Let's try to sneak in one more question here. Cloud is a different environment versus on-site. We don't we do not know cloud provider dependents, who, how, or where they developed. So how can we check on the provider solution?
Yeah, so typically, if it's a trusted cloud provider, they will have their own process for vulnerability and IP compliance. So you can certainly reach out to the vendors and ask. If it is a lesser known provider, right, not the top 3 or 4, you may want to directly engage with them and say that we are leveraging your technology. Our product is going to be running in your ecosystem. Our customers have these demands of quality. Here's the process we use. We'd like to get a disclosure from you, or we're happy to share a tool for you to use. But basically treat it like a supply chain, right? It's something that they are doing, you depend on, and they need to understand your constraints and your requirements to be a good provider to you.
Excellent, excellent. Okay, I think we have time for one more and then that's it. Do organizations like NPM take care of security measures for us already? If so, should we still spend time vetting these OS packages?
Good question. So, do they take care of measures? They take care of as much information up front as they can. So if they know that a package is vulnerable, either someone's reported it or maybe they have their own scanning tools, they will make that known. The thing they don't do that's really imperative your team does is they don't know how you're going to use the package. So it could be that a vulnerability doesn't apply to you, or it could be that it's dormant because you don't use a function, or it could be that it's extremely relevant because it's the infrastructure piece in your application. So a lot of these are, there's a difference between the definition of the security problem and how it manifests itself in your product. So you really need the expertise of your engineering team in context to understand how it applies to you and whether it matters and how to go about remediating it.
All right, great. Well, unfortunately, that is all the time that we have for the question and answer period. If we didn't get to your question, I apologize, but please know that the folks at Flexera will be getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on demand section, and it should be right there waiting for you. Okay, before we close things out, I also do want to do the drawing for the 2 $50 Amazon gift cards. So without further ado, let's go ahead and do that. Let's see. Okay, our winners today are Billy R. Congratulations, Billy. And our second winner is Eric with a CKH. Congratulations, Eric. We'll follow up with the both of you offline via email to get your gift cards to you. So please check your email for that. All right, Alex, thank you so much for such a great presentation. Good stuff.
All right, thank you so much. Thank you to all the attendees. Have a great day.
Yes. Do want to thank everybody for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.